Yes, I think we can start. Hello, everyone, and welcome to Enecuum News and its ninth episode. Today, Serge and I will tell you about the progress over the past week. So don't forget to ask your questions by raising your hand or by typing your question in our English chat. And let's move to the first news. It's about trusted token lists, and we're excited to announce that you can add the information about your tokens, including logos and description via GitHub. And after that, the team will review your request and add your token to trusted. And it means that it will be able to add all drops and farms you would like to create with other trusted tokens to NX interface automatically. So you will not need to fill the Google form to add drops and farms, and everything will be added, as I said, automatically. And the LP token from the trusted token pool will be considered as trusted token as well. So Serge, please add a couple of words about it.
Oh, I think you already described the whole process. Maybe just I want to receive some feedback on how it will be for users to try it. So because we didn't handle the recursive LP on trusted token, so if it will be like LP from a pair from LP from trusted tokens, like something like this. Actually, we didn't try it. It was not our aim to handle such cases, but it may be interesting to test.
Yeah, thank you, Serge. And let's move on. And the next news about our research team at Trinity 2.0, and the team has been hard work on Trinity 2.0, and we've pleased to announce that an article about VRF is almost ready, and we're planning to publish it at a theme conference. So stay tuned for updates in this field, and Serge, please describe in details about VRF, and we have some questions from the community about VRF. So first, I think we can add some information and move to the questions.
Okay, yeah. So I think I'll start with a question about where will you use VRF and why it is so important. So we do not plan to use it. We just study, research how it works, because it is like the most popular source of randomness for blockchains based on Chainlink VRF solution. And we see it as our main competitor for Trinity 2.0 randomness. That's why we go deep into VRF and try to understand its pros and cons. And during this research process, we found a way to improve it. And we want to publish these ideas, approaches, and some mathematical proofs as articles, go to some conferences, just to talk about to start conversation in the field of randomness, and we plan to continue this talk with Trinity 2.0 as a much superior approach. So it is possible that we will implement our update on VRF called decentralized VRF. It depends on our schedule for Trinity 2.0. So maybe it will be reasonable to create decentralized VRF on top of Enecuum network. Maybe not. And this is close to another question from the community. Will you finish Trinity the first 1.0 features, or the team will concentrate at Trinity 2.0? So for development team, the task is to finish Trinity initial, and for research team, it's Trinity 2.0. So Trinity 2.0, it is not ready for implementation. It's just in its way from idea to protocol and then to implementation, and it will be based on many various factors on how it will become live. So for development team, we plan to finish first Trinity. Yes. Next question: why not use VRF from Chainlink? It's quite popular. Or maybe else I will start with another question. How does VRF differ from other random number generation methods? So the idea for VRF is to have a proof that generated number is generated following the rules. So VRF approach is off-chain, and it looks like if you need a random number, you make a call for smart contract. You say, I need a number. And this is the first transaction. Then a Chainlink's node see this transaction and generates a number and then sends this number to the blockchain. So the generation is off-chain. If we stop on this, in that case, Chainlink can provide any number. Yes, it's just based on trust. But the RF algorithm allows Chainlink to create a proof that this number is not just any random number, but actually it was determined by your first transaction. When you said, I need a random number, this transaction determines the outcome. But you as user of randomness, you do not know what exact this random number will be, because Chainlink has a secret private key that is not known for other participants. That's why after the first transaction, random number is determined, but it is known only for Chainlink. And here we move to the last question: why not to use VRF Chainlink? Because in this case, Chainlink has advantage of knowing the random number before all other participants. So when a user needs a random number and makes a transaction, I need a random number. After this, Chainlink already knows the outcome and knows the random number, but other participants do not know. You do not know this random number. You will know it only after Chainlink will publish it. And this situation have different subsequences, and we will describe it in our article. And we have an idea to make this secret of channeling distributed, and it will improve the security of this off-chain generation, but it will be still off-chain. For example, Enecuum network can act as a instead of a single Chainlink node. And why not to use DRF at all and move to Trinity 2.0? Because Trinity 2.0 mining algorithm guarantees on-chain randomness, not off-chain, but blockchain itself generates strong, robust randomness. And this is the main feature that allows not only random number for some DeFi, GameFi applications, but also protects from MEV, maximum value extraction. That is very, very important for different applications and for security of the blockchain itself. I think that is all.
Yeah, thank you, Serge, for your answers, and please feel free to ask your questions via Google form or via chat or in voice form now by raising your hand. And if someone has questions, please raise a hand or type it in this chat. So I see that there are no questions. And thank you, Serge, for your answers and for the development use. Have a great weekend. Thank you, everyone. Have a great weekend too, and see you next week.
Thank you for questions. It was a pleasure to answer them. And thank you. Bye-bye.
Yeah, bye.